Hey everyone, and welcome to the second lesson of Azure Functions University.
Hi, everyone.
So this lesson we're going to talk about everything related to blob storage.
Yeah, it's a lot.
Uh, it is a lot. Yeah, we were like preparing the content the last 2 weeks, and yeah, it grew bigger and bigger. So we have quite a bit of stuff to go through. But before we do that, I want to go through something else. So there's the lesson index, and we'll start the blob stuff in a minute. But I want to highlight that we are definitely accepting content submissions and content requests for new lessons. And luckily, we have already a couple of content requests. One from Christian about Drupal functions, one from Gabriella about Cosmos DB, and one from Sol about securing your Azure functions. So already, thanks a lot for submitting these. We're definitely going to go through with all of them, and yeah, keep your ideas coming, please. Okay. So a blob store, for the ones who maybe haven't heard of a blob store, don't know what it is. So blob storage is one of the services inside a storage account in Azure, and it's ideal for storing unstructured data, and that basically means all kinds of files. So it can be like images or video files or zips or JSON objects, log files, stuff like that. So it's been around since, I don't know, 2012 or something. It's probably one of the oldest Azure services there is. And it integrates really well with functions. So let's get to the lesson. So there's a couple of things which are different now than before, right? Because last time we spoke about the HTTP trigger, and you really didn't need a lot of it to get that running. Just the local Azure Functions runtime. You needed a client to trigger the function. And what we're going to do now, we're still going to write HTTP triggered functions because that's easy for demos. And we're going to first start with some output bindings, meaning we're going to store some data into blob storage. But we also want to make it as easy as possible so that you don't need to connect to Azure right away. So the idea is that you use emulated storage. So we are emulating the blob storage on your local developer machine. So you don't need a connection to Azure. You don't need an Azure subscription. You can just do stuff locally. So Gwyneth, you made some description here. And you prepare some screenshots. So there are a couple of things you should install. The first thing is an emulator, and there are two variations of it. First, there's the Microsoft Azure Storage Emulator. That's for Windows machines only. So that's what I'm running, and that's also what you're running, I think.
Yep.
But if you're not on Windows, then there is an alternative, and that's Azure Write.
Did you see that? I think maybe you retweeted this. There's support for table storage, I believe?
Exactly. Yes, yeah. Exactly. Yeah. So the Azure Storage Emulator is end of life. So it's not being actively developed anymore. But the benefit over Azure Write was that the storage emulator supports blob queues, but also tables. And Azure Write only supported blobs and queues and not tables. But today there was a tweet from one of the architects, Azure architects, that he was working on a preview of table storage emulation in Azure Write. So if you go to the documentation of the Azure Storage Emulator, it also says important, it's no longer being developed, and Azure Write is the way to go. Mm-hmm. So I'm still having it installed because I need it for the table storage, because that's heavily used for Drupal functions, which we'll cover in a later lesson. But definitely, when we're just dealing with blobs or with queues, Azure Write is a very good alternative. So either install it Windows Storage Emulator or install the Azure Write. And if you go the Azure Write route, there are several options. I would recommend you do the Visual Studio Code extension, because you probably already writing your functions in Visual Studio Code anyway. So then you can stay within your code editor. So I'm at the other tool, actually, because this is just the emulation part, but we also want to see what's in our storage. And for that, you can install the Azure Storage Explorer. So this is it. I've made it a bit bigger, so maybe it looks a bit strange. But you can use this Explorer for both your emulated storage, because you can see now I'm activated my emulated storage, and you can see I can look into my blobs, I can make queues and my tables. It used to support also Cosmos DB, but it's being deprecated, and also data lake storage, one of the different storage options in Azure. But you can also connect it to your cloud instances. You can actually go to your storage accounts in Azure. So if I expand the blob containers node, you can see what kind of containers I have on my local machine, because this is the emulated version. And I already have a players container, because if you're in this blob containers node, you can create a new blob container, and you can see a container as a sort of folder. And in this folder, you can create subfolders if you want. So here's a subfolder called in. If we go in there are my blobs. In this case, my blobs are JSON files. And you can see here, there are many things how you can use this tool. You can either drag and drop files in here, you can upload them, and you can download them again to your machine, which sounds a bit weird because we are using emulated storage, which already runs your machine, but you still need to download them from your emulated environment to your local drive. You can open them, create new folders, clone them. So you can do a lot in here. But interesting to note that this folder, so we're now in the players container, but this in folder, that is really a folder, but that's not a container. So if we would remove these files and we would go back, then this folder would actually be gone, because it's more like it's a virtual folder. So it's more part of the file, actually, of the file path, than it's a real thing in the container. All right. So we've covered these things. So let's go to the first example. And the first example will be an HTTP triggered function. So the description we have here is we assume that you'll make a new function app, create some HTTP triggered functions there, and then build them out to contain these blob output bindings. We already prepared some code up front, because otherwise the lessons would take even longer. Yeah. So what I'm going to do is I'm going to show you the code we have, run through the functions, highlight some of the differences, and of course run the function so you can see what it's actually doing. But in this time we won't be coding that from scratch. So this is our Azure Functions Blob project. So that's in the repo, and the repo can be retrieved by going to this link here. So if you go in there and we go to the output folder, I have several examples there, and one of them is with a string blob output. So this function is made by just creating the template HTTP trigger, but then by changing a few things. So in this case, we can see that for the HTTP trigger, we have only enabled the post method. The route is null, and we changed the HTTP request type to be of type of player. And a player is a type that we've defined ourselves. So we've added a player class in our project and gave it some properties. We gave it an ID, a nickname, an email, and the region. In this case, I also added JSON properties to make sure that we have some lowercasing of the properties when these are serialized. There are other ways to do that, but in this case, I've used this JSON property decorations in the class file. So if you do this, whenever you get a post request in with a player data in the request, we immediately have this player object we can work with in the method cell itself, in the function itself. Now what you see here is another attribute, and that's the blob output attribute in this case. And blob output can be used in a couple of different ways. As you see here, the parameters are a blob path and a file access. So what this means, this path is whenever I am saving the output of this function, I'm storing it in this path, players/out, and then slash the file name. In this case, I'm prefixing it with string because I want to show the differences between different output types. In this case, I'm using a string as an output type, so that's why I've prefixed this name with string. And then you see something weird here. You see this rand GUID part. This is called a binding expression. And what this does, that as soon as this function runs and the output is written, it will generate a random GUID. For each function execution, it will run, even with the same payload. It will create a new random GUID and use that as the partial file name in blob storage. And there are a couple of more of these binding expressions. There's a link in the documentation here. So there's also different expressions for date times and for some other stuff. So they can be quite useful. I don't think the random GUID one is very useful most of the time, because usually you want to have a file name which you can refer to. So you need maybe an actual ID of maybe the player in our case or something else. But for demo purposes, this is okay. Then we say we want to write access to the blob storage because we are writing to it. And then finally, we define this output parameter of type string, and that will be our serialized player. Then the body of the function. First, I give a default value of the output string. Then I'm checking if the player is null, and then I return a bad object result. And if the player is actually a valid player object, then I'm serializing it. And I return a accepted, a 202. And then we simply say, okay, return the result. And so we don't explicitly return that player blob. We just need to assign it. And that's because we are using an output parameter here. So as long as this player blob is assigned, it will have the output available. So let's run this. And as before, there are some test files in the test folder. For the output ones, they're called blob_output HTTP. So this one, the store player with string blob output, is using the endpoint of our function. And we're passing it a JSON payload with this content. And since I'm using the REST client, that also has some expression type things you can use. So also this GUID is automatically generated. First, I need to run the function. So let's start it up. So I'm starting the local runtime now. And yeah, then you'll see lots of links because we have lots of HTTP triggers, links for the outputs and the inputs. So it's ready now. So now we can make this post request with this payload. And we get back a 202 accepted. So now let's go to our storage emulator, which is this. And we still have to refresh this.
Refresh it, yeah.
So, and now we have an output folder. So notice that I actually didn't need to create this out folder up front. And so the blob output binding actually created for me. So if you go in that output folder, here we see the JSON with the random string. And if you double click it, then it will be downloaded and then it will open up. Yeah, so here it is. Okay, cool, so that's working. close this one again. So that's one way of doing that. I'll keep this function up running because I'll need it a couple of more times. We've done this sample now. So there are a couple of questions here. So we checked if the blob was there. Yes. We saw the exact path of the blob. So we saw that it also included an out virtual folder there. But let me actually demonstrate now. If we remove this, like I said before, I can delete this. And now I'm still in the out folder, but now I'm moving one level back to the players folder. And now the out folder is gone because there's no data which lives in the out folder anymore. So it's not really there. Okay, so let's go to the next example of output bindings. And that is with a container. So again, we used a default HTTP trigger. We changed again to a post and use the player object immediately. So the HTTP trigger part is exactly the same. But in this case, the blob trigger is different. I've now actually didn't use a direct string. I used an object and a constant string in there called players. So in this example, I'm only specifying the players container. So I'm not specifying a complete blob path to a blob file in the attribute here. Only a reference to the container and that I'm writing to it. And then I'm using a different type, the cloud blob container, which is a reference to the players container. Then I do the same null check as before, but then in the else statement, here I am defining a reference to the blob that I'll be writing. Let me make this a bit bigger. So I'm using a method called getBlockBlob reference, and that will get me a reference to the blob that I'll be writing. And since this cloud blob container is already in the players container, I only need to define the file name part, and that includes the virtual folder then. So here I have out / and then the rest of my file name. And since we're not in the blob attribute, I can actually access properties of my player object. So we don't have to use random IDs or binding expressions or those kind of things. I can actually use relevant information as part of the file name now, which is much more convenient. So the output will be cloudblob hyphen the nickname of the player object .json. We're serializing the player object, and we use the blob upload text async method to write the blob to the player's container. So let's try that. So there's this sample, more or less the same payload, different user this time. Let's do this. Again, we get it to accept it. And let's refresh what we have in storage. Now the output folder is back. And you can see we have the cloud blob and now with the nickname of the player in there. So that's working. A nice thing to show here maybe from what happens if you run the function now with the exact same input. Because we're now, okay, perfect. Because we're not automatically generating a random GUID now.
Not random.
Exactly, so it will generate the same name, but is that allowed? Well, let's just do that to see what happens. And so we are changing the actual content of the file because this ID will be different, but the file name will still contain Margaret. So let's see what happens. I think it's already done. So let's go to the storage again. So this was the previous timestamp, the 918. So let's refresh it. Yeah, so it's 920. So it will simply overwrite what's already there if the file name already exists.
So that's the default behavior. Can you change that if you wanted to?
Yeah, well, I think you should do a check up front because I don't think the method has an overload to actually do that for you. But you should actually then check from is there already a blob? So there are definitely methods available there to do if exists. Okay, and then you just do an if else statement. So if it exists, don't do it. Build your own logic around that. But it's important to realize that you can override things if you didn't use the same file name.
Okay, that's good to know. Gotta be careful.
Yeah, exactly. All right. And yeah, one of the other questions is, can you use other properties of the partial file name? And the answer is definitely yes, because we are now using this. Oh, where is it? It was this. And because this is our player object, so we can use anything as part of the blob file name. We also switch to ID, so we have GUIDs again, but now we have actual then IDs which actually match the ID what is in the content. So that can also be a nice alternative. All right. And let's go to the final example of the blob output. So again, we have an HTTP triggered function, but now we don't have a blob binding. Well, at least not as an attribute here. What we are using is a dynamic binding. And that means we will actually specify which binding we will use in the body of the method and not as an attribute on the method itself. So instead, we are using this iBinder interface. And if you use that, you will see that you can use any binding you want, but you have to define it in code. And the advantage of doing it like that is, you can use some business logic to define which attribute you're using, but also how the attribute behaves. For instance, we can now specify the same as before with the Cloud Blob container. We can use the player attributes of the player in our path. But you can go even further with this dynamic binding. In this case, we're using a blob attribute, but you can also make some logic there that instead of a blob attribute, you are using a table attribute instead, based on your business logic. So dynamic bindings are really a super powerful way of defining your bindings at runtime, actually, instead of compile time. But this time we're still using a blob attribute. As you can see here, we're creating a new blob attribute. We're passing in the complete path. And so players out, in this case now dynamic. And since we have the player object, we can use properties of the player again as our path. What we then do is we use the interface, or the binder interface. That is only one method, bind async. And in this case, we can use a text writer. Another option would be to use a stream. But in this case, we have just small JSON objects. And we can just serialize the player object with the text writer and write it out. So what actually happens, you do the bind async and you specify which object you want to use to write it out to blob. So this output is actually of type text writer. So then you can use the write async method on the text writer to write to your blob. So it's maybe, it's a tiny bit more code because you're now specifying your attributes now in code. It's not that much more of using it in your attribute. And it's, of course, you have to specify how you're going to write to the attribute. But like I said, it's much more powerful because you can really be flexible in determining which attributes you're using and the different options of your attribute.
Do you find yourself using this way of like using attributes more than, I guess, the regular one?
Yeah, and that's mostly because I'm often using parts of a object as part of the file name or in the path, for instance. So it's also quite common that I'm using different virtual paths inside a container, and then also define the name based on certain properties of an object that's coming in. And yeah, more often than not, I then use the dynamic way of binding instead of the other way. Yeah.
Okay.
But like I said, you can even use it by using completely different output attributes. Like I said, you can now dynamically choose between blob or table or Cosmos in your visuals. But I didn't have a use for that yet to be that flexible. But it's definitely an option. So let's run this as well. Yeah, so it's the dynamic binding example. So let's make this a request to accept it already. And let's refresh this. And here's the dynamic one with the actual ID of the user. So if you open this, the ID of the user should be also D0EC. It's opening. Yeah, it is. Cool. Okay. Here we go. Okay, so that's the dynamic one. Oh, yeah. I see a typo in the markdown, but that's fine. I'll fix it. So yeah, can you think of any other scenarios where dynamic bindings are useful? I mean, yeah, personally, I really use it a lot because usually I want to vary things based on certain properties of objects of other services that I'm connecting to. So then I'm quite frequently using the dynamic way of binding. Are you ready to go for the input bindings?
Yeah. No, do I share my screen right now? Hold on. Let me do a little side-by-side action. Get your setup just like yours is. Move this over here. All right. Share screen. Share screen. Share screen. There we go.
Yes,
Whoa.
we have it. Oh.
Hold on.
Uh-oh.
What's that happening? Try again.
Yeah, I also had it once. Usually when I tried the second time, then it was working. So let's...
No, I still see it. Hold on.
Oh, okay.
Wait. Do you see it flickering?
No.
Yes, it is.
Now I do. Oh, no.
What?
What's happening?
And I was, hold on.
Yeah.
I was just sharing my screen too on like a Zoom. So hold on. Share, share, share. No, it's still doing it.
Oh. Otherwise, I will do the screen sharing and you can just talk over it.
Yeah, we can do. Yeah, it's so odd. I guess we could do that. Wow. All right, so we're on. Hold on a second. Let me bring us back over here. Okay, cool. So we're on exercise number 5, using stream blob input bindings. So the following exercises kind of are just like the reverse of what you explained. Instead of getting information out into a blob, we're getting information that we can use inside of our function. So our first one here, and again, it builds on top of an HTTP trigger, which we saw in the last lesson. So we're trying to follow that lesson structure where we're kind of building on top of knowledge instead of just being all over the place. So we hope people find that useful. So if we actually take a look here, I mean, we're already familiar with the HTTP trigger attribute, so we can just take a look at the blob, which again is just following that same blob, then path to where your blob is. In this case, it's players, which is the container, in which is that virtual folder, and then you see it's player dash, and then we have an ID, which is a value that we need to provide. .json. And then again, file access.read, and we're saving this information is going to come into the player stream, which is a stream object. And then we do this validation quite a bit here just to check if the ID is actually given to us, which is just basics. If we do get it, then we go ahead and create a stream reader object, which is going to allow us to actually consume the content that's inside of the stream. So that's where it's the part that says using var reader equals new stream reader, and then there we're providing the stream that we get from the attribute. And next, the content is where we're actually reading the content from that reader. Next, we just create the content, and you see we have the content type, and the status code. So we're just creating what we're going to be returning from the function. And at the bottom, return result, we put it all together and we give that back.
Yeah.
So basically, we're getting the HTTP, we're executing the HTTP trigger function with an ID, and then we're telling the function, hey, go give me the content from the blob that matches this player ID.json file, right?
Yeah.
So we can give this a shot, like a test.
Let's do that. Yeah.
I like how your IDs were like super long, and mine was like 1 player dash 2. Player dash 3.
But that doesn't matter. Okay, so one thing I have to check now.
If we have that,
if the matching IDs are now in my blob storage input. So luckily I gave a session yesterday also about blob storage stuff. So I think I still have some matching data. So let's go to our blob in. Yeah, I've got two blobs. So 470 and 4CE. And that is not this one. So let's copy that.
Yeah, and this is also something we noted in the lesson. Like, make sure you have the actual, like, the correct file, and or else it's not going to work for you.
Yeah, exactly. Yeah. So I'm gonna copy this ID and use it here because this is part of the route. So what we're gonna do is the endpoint is the function name, and then we'll append this ID to it.
Right.
Okay, and the function is still running, so it should be good. Okay. Oh.
Whoa.
Maybe something changed in the name, or let's do some live debugging.
Let's look at what's the file name again?
Get player with stream blob input.
Yeah, that's the right one.
Yeah. Yes.
Get player. Which
here, wait. With stream input. See, there has been some renaming now, but that's okay. So we have a mismatch between the function name and the URL. So we're fixing it now. This is our function name. Again, yes. Exactly.
There we go. We are returned the content of the blob, which is some very simple JSON.
Cool. Nice.
Pretty straightforward, pretty easy, and the differences between like getting it out and getting in are kind of like minimal, right?
Yeah,
you're not
I like
everything.
that. I like that. Yeah, exactly. Yeah. I like the, let's say, the symmetry, but between the two. That's really nice.
Yeah, it's pretty intuitive.
Yeah, exactly. Yeah.
All right, next one, number 6 is, what's number 6? I don't even remember. Cloud blob container. So this is going to allow us to list everything inside, I believe.
Yes, because we are now having a reference to the container itself. So yeah.
Right. Okay, so let's take a look at blah. All right, so here the path is just the name of the container, so there's no virtual folder, no file appended to this. So we're just telling this function, hey, go take a look at just this container here. And then you see that we have the cloud blob container, that where we're actually storing
Yeah.
that. Then we just create a list, which is that blob list there. And then we're going through that container and we're looking at, okay, the blobs that are of type cloud block blob. I think there's 3 types. There's block blob, append blob,
Yeah.
and hold on, I know there's one more.
Was it
Blob,
page blob?
page blob. And
Yeah.
append blobs are like great for, I think, logs.
Yeah.
Page blobs are great for like
VHD image files. Stuff
yeah,
that.
like random reads and writes.
Yeah,
And
exactly.
then blob is like your typical like object storage kind.
Yeah.
Yeah. Okay. Cool. I passed the quiz. All right. So anyway, we're going through all of those. But if you were looking for different types, you could switch your type there.
Exactly. Yeah.
So next
and
from
you actually need to you need to it's convenient to let's say cast this to this cloud blob blob, because the list blob itself just returns an I list blob item collection, and there's very little let's say properties in this I list blob item which you can use. So that's why it's useful to actually
cast it
to this cloud blob blob. Yeah.
Cool. And then we just get the names from that list. Pretty straightforward. And we return that that list. So this function is great if you need to, which I used today. I was going to tell you about that. I was playing around with the Blazor and Azure Static Web Apps, and I used this to list all the blobs.
Oh yeah,
it was great.
Excellent.
Let's run this test.
Cool. Okay, blob inputs.
Check the function name.
Yeah, it's clear. I'll just make sure I copy this. I think it's still the same.
Yes.
So now I'm going to run this bottom one, and indeed, we don't have to provide anything, just the function name itself. And indeed, we already saw before that I have only two blobs in there, the 470 and the 4CE.
We've got a question. Is get player with stream input returning a stream? Not really. No, it's returning the content of the blob. Do we want to look at that one?
The
get player with stream.
This one, right? Yeah.
Yes, that's correct. So it's returning JSON, right? Like, I guess that's the correct way.
Yeah, indeed. Yeah, but that's also because we are also having this request with JSON in there. But in case you have a request with an image attached to it, or some other binary stuff or something, then you need some kind of different processing, of course. So since we are dealing with text, we are just reading this and getting back a string, and that's why we can use it directly as our string content in this content result. But if you're dealing with other kinds of binary formats, then you need to have a bit of different processing here to return something.
Right. So it comes in as a stream, so we can access it as a stream. The way it goes out really depends on what's inside of it and how you want to deal with it.
Yeah, exactly. Yeah.
Cool.
Okay. So the list works. Cool. Then
cool. I think that's it for that one. We have one more.
Two more. The dynamic one.
Oh, this was with the iBinder. Yeah, so this was a concept that I was not aware of, and kind of when you told me about it, it took me a little while to understand it. But then once I did, after being on Stack Overflow and such, I was like, I could see why this is useful. Yeah, but like you mentioned, getting accessing a blob not at compile time but at runtime makes a lot of sense now, right? So this is just like the inverse of the last example that you sent.
Yeah, exactly. Yeah.
And again, if you look at like the actual definition of the method, it's just iBinder and the actual blob attribute's not up there.
That's right.
That's right, moved into the body of the function. Again, we're doing like the simple validation that we've doing, and then we're just going down here. If we do have an ID, we're going to access the blob attribute with a path that we've had, which is the same one that we used in the first example, player/in/player-id. And then we read that content using the text reader. And you also mentioned that we're using text reader in here because it's relatively small, like a small file. But again, this is something that we could change depending on like what's inside of the file. But since
Exactly,
it's a simple demo, we would use this.
And because it's also text-based, indeed. So if it's image data, or if it's a zip or something, then you can still use the stream object and treat it as a stream instead of the text reader. Yeah.
Text reader. So we get the content, and then we again, like the last example, we're creating a result. We're just saying content. Content is JSON status code, and then we're returning that in that result object.
Cool. So let's run that as well. Should we check the names? I think this is okay. No, I also removed the blob from this one. Oh.
Whoa. Yeah. Perfect.
Okay. And the ID should be simply there because it's the same files. And again,
and perfect. It works.
It's working. Cool.
Yeah. So it's very much the end result is similar, but how you get there is like we sent to different options, just because you'll find scenarios where different things are like better. Like I didn't even know this was a thing. So
to be honest, I don't use the dynamic attribute binding much for input binding. I do use it mostly for output bindings, but not so much for input bindings, though.
Yeah, that would make sense, because if you're like working with something and then you need to provide the path, instead of like receiving it in the first place.
Yeah, but there are definitely use cases for you where it makes sense, but I haven't personally run into that situation yet. Yeah.
Someone says, is it possible to return a stream via an Azure function?
I think you can return streamed content. Yes, I think so. Yeah, it's not something I've dealt with, but I think I've seen examples of it. Yeah, I think it's possible.
Yeah. All right, so last one is actually creating. We saved the actual trigger for last, just because we wanted to create it outside of the repo, so we didn't mess up the structure and what we got going on here.
Yes, exactly. Yeah, exactly. Yeah. Let me actually start a new instance then. So, and let me open a folder. Temp, this one. Yeah.
Also, another reason we save this for last is because we actually have to create a storage account for this, versus actually working with emulated storage. So you're going to need to have like an Azure account and all that.
Exactly. Yeah. Which is interesting, because you can work with it purely on emulated storage when you use these bindings, and actually also you can also work with triggers purely on a emulated storage. But the template, the wizard that we'll go through, actually forces you to actually choose either create one or use an existing one in Azure. Yeah. Okay. So let's create a new project. And I did this one actually now okay, because I just made it and opened this, so we can actually create it in here. We will use the C# one, and now we'll choose for the blob trigger. Give it a name. Space. So I think you also described it in the lesson. Yeah, exactly. So we need a file which points to which is a connection string to the storage account in Azure. And if you're developing locally, that file is called local Azure local settings.json.
Mm-hmm.
So we'll need to create a new one because we're just creating a new project, so we don't have any of those files yet. It's also a bit weird why you have this option, because you can only select one thing.
It's
So
the only option.
why not just do it?
Yeah.
Okay. Well, I have multiple Azure subscriptions, so I can select which subscription I'm going to do. But in this case, we are creating a new storage account. I have another existing one. We're not going to do that. Let's create a new storage account. And so this will actually be created in Azure. And if you're going to do this, and if you're putting data in there, that means you also are paying for it. So be aware of that. Luckily, the things you put in storage account is really very cheap. So especially for this example, I wouldn't worry too much about it, but it's a good warning. The name of the storage accounts.
Do storage account names have to be globally unique, or is it just I think it's global.
That's a good point. I don't know for sure. I do know that there are also lots of limitations on what kind of characters you can use, how long it can be.
No capitals, no dashes, no.
Yeah, exactly. So
Can you have numbers?
I'm going for this one. Maybe only for in the end. Yeah, but it definitely won't allow you to actually. Well, if you do this, it will definitely fail. Usually you can have numbers, but in the middle or the end, but not in the beginning. So let's try to go with this one. And let's also create a new resource group. And those can have hyphens, so let's do that. There are actually naming conventions also described by Microsoft, how you which you can apply to all your resources. So usually I use a postfix of 2 characters. So in this case, resource group, it's RG. Storage account, I just it's store, but not ST. But yeah, maybe a bit weird. But when I'm creating a function app, that will be then -FA. It's useful if you choose a naming strategy and really stick to it. It really helps identifying stuff.
Yeah.
Okay, well, I live in the Netherlands, so I'm going to choose something close by, West Europe for me. And now you have to specify the path. Well, we can leave it at the default for now. We used to work with the players container. So this is the name of the container. But let's leave it at the samples work items. It's fine. So now it says, in order to debug, you must select a storage account for internal use by the Azure Functions runtime. So this is interesting because now it actually does allow you to use a local emulator.
Yeah, get it.
That is interesting. So now it's creating the actual resources in Azure, as you can see here, and it's also creating the file, the whole project structure here.
I wonder if they do that because that way you don't have to create it when you're deploying it. Maybe it makes more sense to just have you create it up front, like the storage account.
Yeah, maybe. Yeah, I don't know. It's still a bit weird. I mean, all the way at the end, you can still let's say decide if you're going to use the local development or not. But I would rather have the option more in the beginning. If you can, hey, are you going to go for the local one and only connect to Azure later or not?
Yeah, that last step they should have asked at the beginning. You're right.
Yeah, exactly. Yeah. Okay, so here we go. Let me first go through the files. So we have our CS project file, and what's actually important, and we actually didn't mention that during the other lessons, but if you're using blob triggers or queue or bindings or queues or tables, you have this. You need a dependency to this NuGet package, so Microsoft Azure Web Jobs extensions.storage. And if you create a new function app based on these storage types, it will actually add it for you. But since we already had our Blob project already running, I actually forgot to mention that you actually need to add this dependency to your project. So that's a good one. to stay on that topic for adding NuGet packages and dependencies, I did write it down in the lesson, but I have an extension, and that extension allows me to easily add NuGet packages. And so if you're using .NET Core, you can also use the .NET Core CLI, so the command line to add packages. But I find this a bit more convenient. So I can do add package here, and then you can actually, I'll do it again, but I'll copy paste this to make sure that I'll search for it now. Add package, you can add a partial name of the NuGet package you want to include, then press enter, and then you can see all the available NuGet packages which are on the NuGet.org. But in this case, it's already there, so you don't need to do it. But if you follow our examples and start with an HTTP triggered function, and then want to add the bindings, then you need to add this package, the extensions and storage package, to your solution. And the extension that I'm using is called the NuGet Package Manager. That's again one of the nice things of VS Code, that is really this extensible model with all these extensions. I really like it. All right, so that's the CSports file. The actual function file we'll get to in a minute. There's the host file. There's nothing different in there than we saw before. In this one, the local settings JSON, there is something different. Let's get rid of this again.
Oh, we didn't show this in the other ones, right?
Good point. Good point. Yeah. We'll I'll do it in a sec. We skipped some stuff. Yeah, it happens. So what you see here are some configuration settings for your local instance, and one of them is called Azure Web Job Storage, and so that's a connection string to a storage account. In this case, it's the storage account we actually created in Azure. And yeah, Azure Functions actually needs that to have this. So this key is always available, either locally, but also definitely when you have it published in Azure. This is also created for us because we have now introduced this blob binding. So even if you're not using any blob bindings or storage bindings, you will always need this Azure Web Job Storage connection string, because Azure Functions, we didn't talk about it yet, but Azure Functions has let's say a dependency on a storage account. So it uses the blob store to store the files, right? Because when it's serverless and nothing is actually running, and there's no request to your Azure Functions, it completely spins down, meaning that there's no server anymore which is actually running your code, but your code is still available in a blob in Azure Storage. So that's why this is required. But this one is now added because we are using a Blob Trigger function. And we will see this key also back in our function. So this key points to, in this case, exactly the same storage account, but it could also be a different storage account.
Yeah, it could be anyone that you...
Exactly. Yeah. Okay, so let's go to our function. So we have our generated function name, and here we see, I'm going to give it a couple of new lines so it's a bit easier to read. That's what I usually do. What we see here is our blob trigger attribute. And the first thing that we see there, that it points to a certain container, the container we provided, these samples as -workname / name. And this is again a binding expression. So once a new blob file is being added to this sample work items container, this function will be triggered. And because we have this binding expression here, we will already get the name here available, and we can do something with that name because it's also provided here in a separate parameter. And that's why we can refer to it here in our logging statement. And because the default Blob Trigger function doesn't do anything but logging something to the console. What you then also see is that we have specified a connection string here. That's something I also didn't show in the input and output bindings, because if you don't provide this connection string, so if you do it like this, it will still work. But then it will use the Azure Web Jobs connection string as a fallback.
Mm-hmm.
So it will use the same account. And since we have specified it, it will use this connection string. And what we get is a stream here, and we will have the name of the file, and we have a logger interface, so we can actually log some information. Let's run this. And then we also need to put a blob in our Azure storage. And I'm using this subscription, the sponsorship, and there should be something more here now. Yep. So this one has been created, and well, it's completely empty.
So you gotta create the container.
Yes.
Yeah.
And that was it samples? Sample or samples? What are it?
Samples? Multiple?
Let me just copy paste it. Let me
Dashboard
copy paste it to make sure. Yeah. Let me try it again. Maybe it didn't work okay because I process. Yes, okay.
Cool.
So now we have a container called samples work items. All right. So now I can. We had a sample in our solution, I think.
Mm-hmm. We have a JSON file.
Yeah, exactly. So I'm gonna upload it. Oh, I already have one here. Let's pick this. That's perfect. Let me go back to the function, because as soon as I will upload it, the function will be triggered, and we probably want to witness that. So let me go here. Was it already running? Oh, it wasn't even running it. Let me put in a breakpoint like this. Let me start it now. Okay, so now we have the local runtime is starting. Oh wait, I'm ready. I'm still running the other one. Now I'm running too many functions at the same time. So I'm running two different projects at the same time. So I have stopped the old one with the input and output bindings samples. So now I need to run the one with the Blob Trigger. Oh, I still see an error message, which should be still on the screen. Where is that? I can see it. It's in the it's in the feed, but I don't see it on my own screen. That is very weird. Let me see where it is. Oh no, it was on my other screen. Confusing. All right. So our newly created Blob Trigger function is now running, and we can see one function is available, a Blob Trigger function. We've put in a breakpoint here, so as soon as it's triggered, we will see that. And now let's put in a blob in this samples work items, because that's the container it's listening to. So let's upload the file, this one. And we are uploading it as a blob in this case. Indeed, we mentioned the other types, but usually you do this. This is not of our interest now, because we're not using any page blob, so it's fine. Using the default tier, that's fine. And again, we can specify different virtual folders or directories, but we don't do that now. So let's do upload. So you can see the bottom is now transferring it. And I see something happening here. And the breakpoint is triggered. So, and we see indeed the name is available of the JSON, and we can also access the length of the blob. So it's working. Cool.
Yeah, and if you wanted to access the actual content, we would use that my blob, that stream object right there.
Exactly. Yeah, exactly. Yeah, it's only used here, but only for the length. But indeed, if you also want to read it, you can definitely do that as well. Yeah. Cool.
Yep, we did it. We covered it all.
We covered it all. Yeah,
well,
exactly. Yeah.
Not at all, but we were talking about this, that we think that these are the most popular examples, maybe.
Yeah. Well, our source code in the repo contains a few more samples, because I also have a stream output, which we didn't talk about. We only talked about stream input, but also stream input, but not the output. So there are a few examples there, but indeed there are even more types which you can use in the input and output bindings. It is there in the documentation, but not everything has its own sample. But yeah, I think when you're using small objects, and then strings are fine. Streams and these cloud blob containers are usually better for when you're dealing with bigger, larger objects. So indeed, I think that's usually fine. I still would like to come back to the connection string part. So in our samples, we didn't specify connection strings anywhere, but usually you would. But if you don't specify a connection string, that means the same storage account is used where you deployed your Azure function to. But it's quite likely that you have separated, that you have more storage accounts, and that you want to listen to a complete different storage account, or read or write to another storage account. So then you definitely need to specify this connection. And what you need to realize is that you're not putting a connection string immediately in this value, because this connection means the name of the application setting. So right now it refers to a storage account application setting. So that means that it needs to be available here in your app settings. So this is then either a connection, and so here's the real connection string to Azure if you want to read something from an Azure storage account, or like in this case, you can use this special connection string, which indicates that you're using emulated storage. And that was what we forgot to mention.
Kind of important.
Kind of important.
Just a little bit.
Yeah, but we're still saying it now. Yeah. And so now Azure Functions uses the local emulated storage, and also whenever blobs have this storage account key specified, that also uses emulated storage. So that's important to realize. Don't put the real direct connection string in here. This just refers to an application setting here. Yeah. And when you are deploying to Azure, then you also need to have this storage account app setting available in your deployed function there. But we'll do a separate session about deploying function apps to Azure. I think we need to do that rather shortly.
Yeah.
Okay.
All right.
So we got it all. We've shown the trigger. We've mentioned the connections, input-output bindings. It is a lot. Yeah? So it's definitely a lot to take into.
Imagine if we actually wrote all the code out from scratch, like we originally.
Yeah, exactly. No, indeed. Yeah. I think the format will be like this, that we definitely have prepared some stuff in advance, because indeed, otherwise it will definitely take longer and longer.
Yeah.
Yeah, so we went through the sample, you've run it indeed, yeah. So
Oh, the homework.
ooh, yes. Tell me about it.
It's building off. So hopefully you did the one for the HTTP trigger, because this one is just building off that one. So really all you have to do is, instead of putting your JSON directly inside of your function, save it in, a blob container, and then have your function pull the content from that blob and
Yeah.
then display it, like you would. There's
Yeah.
some resources in here, some tips, and there's also, of course, a solution. But try to do it first.
Yeah, exactly. Yeah, exactly. Yeah.
It's insane how simple,
It's not a lot of code you need to write. Yeah,
yeah.
exactly. Yeah.
If you go through the lessons, you're going to instantly know which one you have to use and how to set it up. So, but it's good, and we're gonna try to keep building on that same as much as we can, that same exercise.
Exactly. Yeah, and at the end we'll have just a full-fledged API product which we can sell, right?
Yes.
Yeah. It's a secret side business. We just create lessons and then create products as a result of it. Yeah, that's pretty cool.
Yeah. Yeah, I think that's it. What can they expect for the next lesson?
Yes.
We don't know yet. Do we know?
Well, yeah, I have a slight preference. Let's go to the index. I still want to do this order. So first the queues. But maybe after the queues, maybe we should talk about actually deploying to the cloud. Because we are still working locally, and which is good, which is nice. But soon we'll be running into issues, into situations that it's really also easy to actually see how it's actually behaving in the cloud.
Right.
So these three, and there are emulators for all of these still, but maybe queues and then deployment to the cloud lesson, and then continue with table bindings and then Cosmos DB and many more to come.
Yeah, we're just getting started.
yeah, and yeah, as we mentioned, please keep ideas coming. If you want to contribute by writing a lesson and also hosting it with us and then going through your demos, please contribute to these things. We're just scratching the surface so far, so there's still a lot of material that we can go through. So please help us out.
Please.
All right. Well, thanks a lot. Yeah, as you mentioned, you learned a lot, and even I also learned a lot, even though I've used quite a bit of this blob binding. But yeah, as soon as you're making all these learning materials, you also learn quite a bit more yourself, which is always a nice experience. So I like it. Okay. So let's see you in 2 weeks again for the next lesson about queues.
Yeah. See everybody.